Hello everyone, this is Rishi Yadav. Today we are going to discuss about differential equation. First is what is differential equation. First thing is the differential equation consists of two variables. First is dependent variable, second is independent variable. If dy over dx is written, that means y is dependent variable and x is our independent variable. Next is what is the order of differential equation. So the order of differential equation is the order of derivative which is contains. Suppose this is equation dy over dx minus sin x. This is first order derivative. If here is written d2y over dx square, then the order will be 2. If here written d3y over dx cube, this means order is 3. Next is what? Degree of differential equation. So degree of differential equation is the degree of the highest order derivative. What is degree of differential equation? Degree of differential equation is the degree of the highest order derivative. If we look at this equation, so in this equation d3 cube upon dx cube whole square plus x d2y over dx square plus 3y dy over dx. First what we have to see, we have to see that which is the highest order derivative. So here d3y upon dx cube, it is the highest order derivative. So the order of this differential equation is 3 and degree of this is the degree of the differential equation. So degree of this is 2. So what will be the degree of this given differential equation? Degree will be 2. One thing you should remember, if dy over dx, if dy over dx is written inside any function, suppose is written log dy over dx, then the degree will be infinite. Suppose if written sine dy over dx, then also degree will be infinite. So if dy over dx is written inside any function, then the degree of that differential equation will be infinite. Remember this. Next is the types of differential equation. So there are mainly three type of differential equation. First is variable separable differential equation. In a variable separable differential equation, what we do, in variable separable differential equation, we move y to the side where dy is written and dx, and all the x to the side where dx is written. Then we integrate both of them. Next is the homogeneous differential equation. Next is what? Next is homogeneous differential equation. So in homogeneous differential equation, x and y are written in divided form. How? X and y are written in divided form. Suppose if it is written that dy over dx is equal to x upon y, x upon y, if or any function fx upon gy, this is written, then this will be what? Then this will be homogeneous differential equation. Then what will be this? This will be homogeneous differential. Remember that all the terms of x and y, should be of same degree. All the terms of x and y should be of same degree. Next is what? Next is the linear differential equation. So in linear differential equation is of the form dy over dx plus py is equal to q. Dy over dx plus py is equal to q. We get the value of p and q. Then what we do? Then we find the integrating factor. Then what we find? Integrating factor. Then this integrating factor is nothing but integrating factor is e integration p dx. Next we solve this. How we solve this? We solve this by applying formula by into integrating factor that we have got from here. So by into if into q that we had got from here. This by into integrating factor integration q into integrating factor dx plus c. This is how we solve. Let's see how to identify the given differential equation. How to identify whether given differential is homogeneous or linear or variable separable. For that we will look only the questions which have been asked in the previous year by the board. So look this equation. What this is written: by plus log x dx minus x dy equal to 0. We are given that at y equal to 0 x is equal to 1. So this type equation is given. So what will be our first step? Our first step will be to find dy over dx. What will be our first step? Our first step will be to find dy over dx. So this is our question: by plus log x dx minus, first what we find? First we find that dy over dx by plus log x upon x. Here we see that this log x function is there. If any function is in the terms of x, then that equation will be definitely linear differential equation. What will be the type of equation? The equation will be of type linear differential equation. So this is the form of linear differential equation. This is the form of linear differential equation. So this we can write that by upon x plus log x upon x. So dy over dx, this plus, we will, when we will move it to left hand side, then it will become minus y upon x is equal to log x upon x. From here we can p by, so minus 1 upon x into y. So p is minus 1 upon x, q is log x upon x, and then we will find integrating factor, which e integration p dx. What is p here? Minus 1 upon x. So here what we e integration minus 1 upon x dx. So e minus log x, e log this will move here, this minus will move here, as we have seen that what 2 log x, 2 log x is log x square, so this minus will move here, then x to the power minus 1, x to the power minus 1 is 1 upon x. So e to the power log 1 upon x, and e to the power log e 1 upon x, it is equal to 1 upon x. So here we will get 1 upon x. Then by the same formula we will solve what? By into integrating factor. Integrating factor is 1 upon x, so y into 1 upon x, it is y upon x is equal to integration q. What is q? Log x upon x, into integrating factor. What is integrating factor here? 1 upon x dx. So we will solve this, and finally we will get the answer. So second, look at this question: x square plus xy plus y square dx equal to 0. What will be our first step? Our first step will be to find dy over dx. What will be our first step? First step will be to find dy over dx. We will get minus xy plus y square upon x. Here we see that degree of y is 2, degree of x and y is xy. Degree of x into y is always 2. Degree of x into y is always 2, because these both are variables. X and y are variables, so the degree of whole term x and y will be 2. So x, this degree 2, this degree 2, and x degree 2, all the degrees are same. That means it is a homogeneous differential equation. What is it? It is the homogeneous differential equation. And how we solve a homogeneous differential equation? We consider y is equal to vx, then we differentiate this. Y is equal to vx, we differentiate y is equal to vx. So differentiation of y is equal to vx will be dy over dx v plus x dv upon dx. Differentiation d over dx of u v. What it is? U dv over dx plus v du over dx. This is the multiplication rule in differentiation. So if we differentiate this, by differentiating we will get dy over dx is equal to v plus x dv over dx. Then in place of here we will put this v plus x dv over dx, and in place of y we will put vx. In place of y we will put what? Vx. We will put vx. Next we will solve it. And we will move terms of x to one side, move terms of x to one side, and all terms of v to another side. Then we will integrate both the equation. Then what will we do? We will integrate both the equation, and by integrating we will get our final answer. And in our final answer, do remember to put the value of v by upon x, because we have considered y is equal to vx. So we will put here v is equal to by upon x. Next we will solve it and we will finally get the answer. Next, look at this question. Look at the question number 70. What is this question? This has also been asked in the board exam. So by minus x dy over dx, by minus x dy over dx is equal to x plus y dy over dx. What is our first step? Our first step is to, what is our first step? Our first step is to move the terms dy over dx to one side, and remaining all terms to another side, What we will do? by minus x dy over dx is equal to x plus y dy over dx. So by this x we will move to left hand side, and this we will move to right hand side, and then we will take dy over dx common, then x plus y by minus x x plus y. We see that degree of x is 1, degree of y is 1, degree of x is 1, degree of y is 10. All the degrees of the terms x and y are same. That means it is a homogeneous equation. What it means? It means that the given equation is a homogeneous equation, and then we will finally solve the way we solve the homogeneous differential equation. How we solve the differential equation? We solve the differential equation by first differentiating y is equal to vx, and then substituting value y is equal to vx, and then finally solving it. And by solving it we will finally get our answer. Next, move to the question number 63. It has also been asked in the board examination. By plus log x dx minus x dy. By merely looking at the equation we can see that here log x is there. If anywhere the function is in the, if x is inside any function, then it definitely means that it is a linear differential equation. What is means? It is a linear differential equation. So our first step will be to find dy over dx. We have find dy over dx is equal to y upon x plus log x upon x. Here we can see that what is the form of our linear differential equation. So the form of linear differential equation is dy over dx plus py is equal to q. Then we will move this equation to the form dy over dx plus py is equal to q. So dy over dx, this will move to right hand side and it will become negative. So minus y upon x is equal to log x upon x. So p, what p is? P is minus 1 upon x and q is log x upon x. Then we will solve it the way we have solved the previous question. Simply we will find integrating factor, and after finding integrating factor, what we will do? We will do that by into integrating factor, integrating factor into q dx. What is the solution of the linear differential equation? By into integrating factor is equal to integrating factor into q dx, integrating factor into q dx, integrating factor into q dx. So this is how we will solve it. So finally we will get our answer. Next, move to the question number 54. Moving to the question number 54. Here what is written? x y square plus x dx is equal to x square plus y dy is equal to 0. What will be our first step? Our first step will be to move all the dy over dx to one side and all the remaining terms to another side. So we did as that. We moved all the x square y square upon x square y plus y and dy over dx to 1. We see that degree of x into y square, then the degree of this whole term is 3. Degree of x is 1, degree of y is 1, and degree of x square y is 1. Then this means that it is neither a linear differential equation nor a homogeneous differential equation, because all the degrees are different. So what is remaining? Variable separable. What is remaining? Variable separable. And what we do in variable separable? In variable separable differential equation, we move all the x terms to the side where dx is present and all the y terms to the side where dy is present. So we did as that. X upon x square plus 1 we kept this side, and dx we multiply this side. Y square plus 1 upon y we moved this to right hand side, and we got this will be here. By cross multiplying we will get minus x upon x square plus dx by upon y plus 1 dy. Then simply what we have to then simply we have to integrate it by applying the integration rule. This is how we will get the final answer. Next, move to the question number 54 52. This has also been asked in the exam, by ICSE exam. X plus 1 dy minus 2xy dx is equal to 0. So what will be our step? Our first step is to move dy over dx to one hand side. So dy over dx is equal to 2xy upon x plus 1. We can see here the degree of 2xy is 2, degree of x is 1. So this is not a homogeneous differential equation, and here no function is present like log x. So this means this is also not an linear differential equation. This is also not an linear differential equation. Then which one is remaining? Variable separable. And what we do in variable separable differential equation, we move all the terms of x to dx side and all the terms of y to dy side, and after that we integrate it. And after integrating we got this final answer. Next, moving to the question number 45. This has also been asked in the word examination. See, so 1 plus x square dy over dx is equal to 4x square minus 2xy. Moving dy over dx to one x side and remaining all terms to another side, we will get that dy over dx is equal to 4x square minus 2xy 1 plus x. Here we see that degree of x is 2, degree of this is 2, degree of this is 2, but degree of 1 is only 1. So this is not a homogeneous differential equation. Then we will check it for the after that we will check it for the linear differential equation. What is the form of linear differential equation? Form of linear differential equation is dy over dx is equal to p by is equal to py it is dy over dx minus py is equal to q. So this we have to look that whether py is present here or not, py is present in the equation or not. From here we can see that 4x square minus 2x upon 1 plus 4x square 1 plus x square and 2x upon 1 plus x. This y is here. That means py is present here. If py is present here, that means it is the linear differential equation. What it means? It means it is linear differential equation. We will change it to the form dy plus py is equal to q. So we change it to dy over dx plus 2x on 1 plus x square into y equal to 4x square 1 plus x square. So we will get p is equal to 2x upon 1 plus x square and q is equal to 4x upon. Then we will find the integrating factor, and after that we will solve it the method we used to solve it. What? By into integrating factor is equal to integrating factor into q dx. This is how I hope that you must have understood this. For any doubt, please ask. I will tell you. Thanks for watching. Thanks a lot.